All right, so I'm here today to walk through what exactly we're doing with this data that we gathered in the previous video. The previous video, if you haven't watched it yet, it is me charging up two balloons and letting them hang and seeing the separation distance. So that's what you see in this picture right here. And the purpose of this lab is to determine the number of excess electrons on a balloon. And it's really an exercise in utilizing Coulomb's law in conjunction with free body diagrams. And this whole lab, actually, the process that we're going to use to solve it is very similar to the When Pigs Fly lab, where we had the pig flying around in a circle, and we used the two triangle. I called it the two triangle method. The one triangle is the free body diagrams. The other triangle is going to be the physical measurements, and we'll be able to do that, or we'll be able to use that to determine how many excess electrons are on the balloon, and those excess electrons are what are causing them to repel. So if I were to start, I'm just going to start by making a quick little free body diagram. So if I isolate this balloon right here on the left, there is of course a tension force going up and to the right. There is a weight force, even though it's really small, going down. And then there is a electrostatic force pushing it to the left. And that is because if I charge both the balloons, they will both experience an electrostatic force, equal and opposite directions. So equal magnitude, opposite directions. So we can use this to determine how many excess electrons are on that balloon. All right, so how are we going to do this? Well, we already started with this free body diagram, so let's go ahead and let's kind of isolate that and on a new page. So with my free body diagram, I have the weight, I have the tension, and I have the electrostatic force. Okay, now the tension, it's important to note, has both an x component, tx, and a y component, ty. Now, if I have tx and ty, that actually makes this really easy because this is in equilibrium. So tx is, of course, equal and opposite to Fe, and Ty is, of course, equal and opposite to the weight. So if I have Tx, I can determine Fe. And if I have Ty, I can determine Tx. So I have a lot of information here. What I do have is the weight. Oh, wait, but that's it. That is all the information I have right now. So I can utilize that to solve my other components. So my first step one, is I want to find the angle that this is hanging at. I want to find that angle. And in order to do that, I'm actually going to set up another triangle. So if I were to draw this again, I got my two balloons. They're hanging from pieces of strings. So there's some separation distance between them. And then if I were to drop a vertical line there, this angle right here would be the same angle as this angle right here. So this is just, of course, the length of the string. So if I have the length of the string, that would be the hypotenuse of the triangle. If I had the distance, well, the distance is kind of the opposite, but really the opposite of the angle, but really this is d over 2. So I can determine the angle by taking a look at that. So if I use the sine of theta equals opposite, which is d over 2, over the hypotenuse, which is L, I can figure out that angle, because of course sine inverse would be d over 2 over L. d over 2 over L. So my angle is the separation distance, which I already gathered, divided by 2, divided by the length of the string, and I take the sine inverse of that. So that's your step one, is to find theta. Once you got theta, you're good for step one. Step two is, well, let me draw my free body diagram again. I got my tension, I got my weight, and I got Fe, and I split these into components, Tx, Ty. All right, awesome. Step 2 is, now that I have this angle, I can use that angle with my knowledge of Ty to solve for the weight. Or I'm sorry, to solve for Tx. So what do we know about Ty? Well, if I were to set up, so here's step 2. I want to find Ty. Because if I have Ty, I can get Tx as well, right? So to get Ty, I can use Newton's law. So the sum of the forces in the y direction equals the net force in the y direction. And since this is balanced, it's going to equal 0. Going in the positive direction, I have Ty. In the negative direction, I have the weight. Those will equal 0, which means that Ty equals the weight, which equals, the weight is just equal to mass times gravity. So with that, I can get Ty. Well, with Ty and the angle, step 3, so you need to solve for this, obviously. So step 3 would be to find Tx. So I have Ty and the angle, and with that I can get Tx. So I'm going to go back to my free body diagram, and I'm just going to look at the tension here. So I got tension, that's the overall tension. I have Tx. I have Ty. And this is, of course, a right triangle. So if I have Ty, because Ty is mass times gravity. I have this angle, and with that, I can get Tx. I have opposite and adjacent, so I'm going to use tangent. So tangent of theta equals opposite, Tx, over adjacent, Ty. So I have just Tx over Ty. Well, that means that Tx is going to be Ty tan theta. And where Ty is, of course, just mass times gravity. So I can get Tx from that. So Tx equals Ty times, which is mass times gravity, times the tangent of whatever that angle is that we got previously. All right, so with that, I can go to the next step because I know that Tx is equal and opposite to the electric force. All right, so now that I have Tx, I can pretty much finish off this slab. Now Tx, so with Tx, let me draw my free body diagram again. So there's my weight, there's T, and of course we got Tx, and Ty, and Fe. So if now that I have Tx, I know, of course, that Tx equals Fe. And how do I know that? Well, this is an equilibrium, so my x components must balance way back from unit 2. So that means that Tx has to equal Fe. So step 4 now, because remember the purpose of this lab is to determine the number of excess electrons. From that, I can get Q. I can get the charge on the balloon. The charge on the balloon. And the way that I'm going to do that is that I know that Tx and Fe are equal, okay? So if I were to, so the sum of the forces in the x direction equals Tx minus Fe, and that, of course, is going to equal 0. So we know that Tx equals Fe, so Tx equals Fe, but Fe equals K Q1 Q2 over the separation distance squared, where Q1 would be the charge of the one balloon and Q2 is the charge of the other balloon. So I'm going to go ahead, and I said this in my explanation video or my demonstration video, that let's assume that both the charges are the same. That means that this is not KQ1 Q2 over R squared, it's KQ squared over R squared. And with that, I can get Q equaling the square root of Tx, because Tx is taking the place of Fe, times R squared all over K, which is Coulomb's constant. Now, Coulomb's constant, just a reminder, is 9 times 10 to the 9th Newton meter squared per Coulomb squared. So that will give me the charge on that balloon. And when I have the charge on that balloon, we get on to our last and final step. So the concept of charge, so here's step 5, is to find the number of electrons, the excess or lack of electrons. The concept of charge is very simple. If something is charged, it has extra electrons or it lacks electrons. And the way that I can say that then is that its charge is equal to the number of excess or lack electrons times the charge of one electron. So the number of electrons, it's the total charge divided by the charge of one electron. So I take Q, which was what I got in step 4, and I divide that by E, which is 1.6 times 10 to the negative 19th coulombs. So if I do that and I divide those two numbers, I should get a very, very large number. If you get something small, you did something wrong, double check your parentheses on your calculator and whatnot, but you should get when we're talking about extra electrons, we're talking about millions and billions of electrons. So it should not be a negative number. It should not be a times 10 to the negative number. It should be a large positive number. And that is the number of excess electrons on your balloon. So what should be in your notebook? Well, I walked you through the derivation, but I didn't actually plug in any numbers. Obviously, we're going to have to do that. So start off with the purpose. That should already be there. Why are we doing the lab? A detailed step-by-step procedure. So the procedure should be detailed enough, as always, for a peer to follow. And we want a diagram of the experiment. We want a diagram or a picture of what the experiment looks like. The next little chunk is kind of your calculations section. And in that, we want a free body diagram, because this helps us guide through all of the derivation. So you should have a derivation or the calculation determining the number of excess electrons. Now, there's no way that we could actually go through and count all these, right? So we can't really do anything, any data analysis with percent error or anything like that. One thing we could be more precise about is actually physically charging it with electric current, and there's some other things we could do. A little higher level stuff, we're not really going to worry about that, but that is it for this lab.